everyone, welcome to section B of our introduction to sequential circuits. Previously we introduced sequential circuits in section A and we had started with latches. We started with the basic SR latch and then we added the control, the enable, and then we introduced the D latch. So, just briefly, latches respond to trigger labels on control inputs. It is difficult to precisely time when to store data with latches, and it is transparent. Its input value can be seen from the output. Now, flip-flops store data on rising or falling trigger edge. Actually, they are edge triggered. Okay, data remains stable in a flip-flop until the next rising edge. So the path is broken before it can change. So when you add clocking to a D latch, you get a D flip-flop. In fact, the control, what we were looking at the control can be the clock. So I get a D latch with the clock as the C input is a flip-flop, the same circuit we had. And they are actually level triggered. So here, the value of Q will follow what is on D, actually at a positive when C is 1, when the clock is 1, when it goes to 1, positive edge triggered. Okay, when the clock is 0, then it's in memory. It's the same diagram. So this is the symbol of a clocked D flip-flop. Positive edge triggered when the clock goes to 1. What is at Q follows what is at D. That is the symbol, and that is the clock showing its positive edge. You can see that triangle there. So here is your D and here is your clock. So what is the behavior? Assume what is at Q. Assuming Q starts at 1. At the clock, positive edge, it will sample D, so D will go to 0 there. And then it will remain in memory until the positive edge, it's 1, goes to 1, in memory, goes to 0, in memory, goes to 1, in memory, still 1, goes to 0, like that, 0, easy. Now, as a class exercise, this is what you expect to do. This is the first thing that will show you understand what a D latch with control and what a D flip-flop is. So this is not done in class, but note that is what you should get as your answer. So you've got the clock, you've got the D. So you should know what this is. Is it a flip-flop or a latch? You should check. Is this on a flip-flop or a latch? You should check. I'm leaving you to decipher that. Is this on a flip-flop or a latch? At what level is it, at what age is it triggered? So do that and then make sure you get that correct. It's when you will understand that. Now the next one is what we call the JK flip-flop. Here is your J, here is your K, and it's made from the transparent D latch. And there is the clock. So you can work out and get your combinations of your function table. Actually, some questions in the exam can ask you to derive that. So what happens here? If J and K are 0, 0, no change, it is in memory. If J and K are 0, 1, it is reset. K is looked at as a reset and J as a set. When J are 1, 0, it is set. Now, it has eliminated that the previously undesirable condition. When J and K are 1, 1, it toggles. Remember, toggling. If it was 0, it goes to 1. If it was 1, it goes to 0. So that is the symbol of the JK flip-flop. JK, QQ complement, and the clock. That is the implementation. So timing diagrams, you have to complete. That is the function table. So determine Q and Q complement. Let's see. Here is your clock. And it is positive edge triggered. When J and K are J and K are 1, 0. So what happens when the clock goes 1? It will be set. And then it will remain there up to when the clock goes high. J and K are 0, 1. So that is reset until there. They are 0, 0 in memory until positive edge. J, K are 1, 0 set until positive K. J, K are 1, 1. 1, 1. 1, 1 means toggle. If it was 1 goes to 0. You can do that for the Q complement. So that is our JK flip-flop. The next one is a T flip-flop. This is how it is implemented. Okay. This, you can look at it as that. And this is its symbol. So what you can, from this you can derive this function table. It only has one input and there is a clock. When T is 0, it is in memory. When T is 1, it toggles. So you've got the clock here and then T. So let's look at what happens that. Remember, all those things happen at the clock, at the positive clock edge. So when the positive clock edge here, T is 1. So 1, it toggles. So if it was 0, it will go to 1. There. Goes positive clock edge is here. Here. T is 0. If T is 0, it is in memory, so it will be in memory. Until the positive clock, T is 1, toggles, goes to 0. Until the positive clock, T is 1, toggles, so it will come up until the positive clock. Simple. That is how our T flip-flop is. The next one is what you call a master-slave D flip-flop. Can be a master slave JK, but we are looking at the master slave D flip-flop. So you've got two latches. You've got the master latch and the slave latch, which you can look at that as a clock or an enable. So when you have it like this, the first circuit samples D at any time. Look at how the clock is connected. When it is high, it enables the master. When it is low, it enables the slave. So the slave will only respond to the master when the clock changes from high to low. You can even look at it as negative edge triggered for this particular one. But we say they are pulse triggered. The slave will only respond after the pulse. They are called pulse triggered flip-flops. That is enabled when the clock is high. That is enabled when the clock is low. So let's look at that. To be on the good side, we have QM and Q slave. Remember, this is our final Q. So here is the clock. Okay, the clock is low. Here is the slave enabled. So QM doesn't really do much in memory. The clock is high. QM follows what? D. So it has to go there up to there. Okay. When this goes low, it is in memory. Until the clock goes high, follows D, goes low. Okay. There in memory. When it goes high, follows D, goes up. Like that. Then QS follows QM when the clock goes low. So when it goes low, follows QM, comes high. Then it is wait until the clock goes low, follows that is low. Wait, when it goes low, goes high. So if you check carefully, it operates after the positive. The value of Q is affected after the positive pulse. That is why it is called a pulsed flip-flop. After the pulse, Q takes the value of QM, actually the value of D after the pulse. So that is why they are called the pulsed flip-flop. We've got the master slave flip-flop, master slave SR flip-flop, S and R. You've got the clock. These are the connections. That is the sign of saying they are pulse. You've got the clock, S and R. You can work out Q. And I'm not going to give the answer. Don't wait for the answer. Then you've got the JK, master slave JK flip-flop. It is made from the SR. Then you've got the clock. got the JK there, but it's made from SR, and then the clock. That is the symbol. So can you determine QM and QS? So let's see what goes on here. JK, when the clock is low, remember it affects the master, which gives you QM. Okay, let's see. When the clock is low, QM is in memory. When the clock goes high, J is 0, K is 1, it will be reset. Are we together? And then let's go QM. Okay, and then here, remember it is a pulse. When J goes high, K goes high, 1 1, it toggles, so it will toggle here, then up to, toggles up to here. Then here it is in memory. When it is high, J is 0, okay, K is 1, it will be reset. This is just a delay in my drawing. It will be reset, and then it goes 0 0, it will keep memory up to there, okay, and then here it will keep memory up to there, and then when enabled 0 0, memory up to there, and then it's 1 0, it will be set there, okay, then 0 0, memory up to there, then keeps memory there, then 0 0, memory up to there, reset. There you have 1 0, it will be reset up to the memory, so that can be gotten. Now this one, when after the negative pulse, it takes on the value of what? QM. Just that is the value of QM after the negative pulse. Comes here, takes on the value of QM. When the negative pulse starts, takes QM. That one, when the negative pulse starts, takes QM. When the negative pulse starts, takes QM, and like that. So this one actually acts like, the last one acts like a D flip-flop. You can check it, they are pulsed. But you must be careful what happens to the first one during the first enablement, the first pulse. The next thing we want to talk about are synchronous inputs to all our flip-flops. We have asynchronous inputs like a synchronized preset and clear. In this case, if preset is low, doesn't matter what the values are, this Q will be preset. If clear is low, doesn't matter what happens, Q will be what? Clear. You mustn't assert both of them at the same time. Synchronous inputs are used to force the flip-flops to a particular state independent of the clock. The input that sets the flip-flop to 1 is called preset, or the input that sets the flip-flop to 0 is called clear. And they are actually, it doesn't care about the clock. Once it's asserted, that happens. So use that to derive that, to determine the timing diagram. Once the preset goes to 0, it doesn't matter. This is preset. Once it's active, it will be set. And once the clear is active, it's active low, it will be cleared. So use that to get that. This is how their synchronous inputs are just wired, to show you how they are wired and why they are more superior to the clock. So parallel data transfer uses several flip-flops. That is flip-flop 1, 2, 3 to get your memory, your bytes of data. So this is a summary of the characteristic table of a JK, SR, D, and T flip-flop. They are all given in the exam. There is no need to memorize, but you need to understand their functionality. So there are chips that come with latches and flip-flops you need to know. I've just added these slides for extra information, like the 7474, 7476. When you see that is positive, edge triggered, this is a D flip-flop, this is a latch. You can see it's not level sensitive. The timing diagrams are there. You can do the timing diagram. So the summary of what we have done today, you've got an SR latch, SR NAND latch, D flip-flop with the control, which is active high, control active low. You have master slave pulsed triggered. You've got the SR negative pulse, Then we've got the JK and JK negative pulse, and then we've got the D flip-flop, JK and JK, positive and negative edge triggered. So that is what you should understand, the functionality of all this. So you need to know how to choose a flip-flop, whether you want a large, a JK, a D flip-flop, T. All of them can be made from the same, but the D is the most common one. So D flip-flop, the simplest and most widely used, and it's the fastest. It's the most common one. Thanks.